It's all random, genetic, epigenetic events that somehow are selected for based on just the overwhelming burden of the number of cells and the genetic diversity that's present in a tumor mass. It's got nothing to do with purpose. It's got nothing to do with cancer cell having an eye to the future. It's total chaos.
Charles Swanton's office is located in central London in this building, which houses the Francis Crick Institute and its 1,500 scientists dedicated to biological research. A medical doctor, Charles Swanton chose oncology as his speciality before focusing mainly on research.
Patients would often ask why. I did so well for the first 3 to 6 months, and now the tumour's, developing resistance. Why is this, doctor? And I'd say, well, honestly, I don't know, but this all feels to me like Darwinian resistance, Darwinian evolution of acquired resistance, much like bacteria acquire resistance to antibiotics.
Darwin's principles of evolution could explain how a cancer evolves, changing over time and as treatment is administered. This has been the basic idea underlying Charles Swanton's work for many years. Before his time, several scientists had proposed the hypothesis that tumours are not made up of identical cancer cells, rather that they are truly heterogeneous. This represents an unusual and novel approach to considering cancer.
You might assume that every cell is pretty much the same, and the tumour is a tumour no matter where you look. Some of the pioneering work from Charlie's demonstrated that if you take multiple samples from a tumour, there's striking amounts of diversity, that no two tumour cells are actually identical.
Tumours and these collections of cancer cells have distinct populations, or what we call subclones, where some of the properties or features are in common and shared, but they are distinct and unique from another part of the tumour. And we're trying to understand how have they evolved. How does one bad cell become multiple collections of groupings of cells that have these features that can be distinct?
Charles Swanton set up a large-scale project, the TRACER-X Lung Cancer Evolution Study, to confirm this hypothesis and also to understand which factors shape the evolutionary trajectory of a cancer. This lung cancer study is being undertaken in the United Kingdom and combines clinical, histopathological and genomic data.
Lung TRACER-X is a longitudinal clinical study which aims to explore the impact of intratumour heterogeneity and its association with clinical outcomes. We aim to recruit around 842 patients. We're just over halfway now in our studies of exploring the impact of tumour heterogeneity and disease recurrence.
What TRACER-X did was said, well, let's take multiple samples of the tumour, analyse each one of those, and not just look at the genomics, but also look at the ecosystem of the tumour, the environment in which the tumour is sitting, and try to explore all that together, not just look at one point in time, but over time.
Through all of that, we now have this sort of window on the world of tumour evolution that, I couldn't have imagined 10, 15 years ago.
Charlie's really sort of opened up a whole new way of thinking about cancer, which has been very revolutionary. This whole idea of cancer as a continually evolving organism that keeps changing in response to challenges that it may have.
The work that we've been doing is quite revolutionary because if we wouldn't be able to understand how prevalent heterogeneity is in solid cancers and also be able to understand why these solid tumours are so difficult to treat.
It's also important clinically to understand that when a tumour is diagnosed, if it's heterogeneous and it's evolved, it will continue to evolve. So relying on one biopsy that may be many years old will never be adequate enough to give you the full information you need to make treatment decisions.
The objective of the research is to understand the evolution of the disease in all its diversity and to avoid recurrences. This means identifying the next stage towards which a tumour might actually evolve. This can be both contrary to normal expectations and quite unforeseeable.
It's not clever at all. It's just simply a reflection of the overwhelming burden of disease and the genetic diversity that encompasses it. And the order comes about through natural selection.
It's a matter of understanding the rules of the game. The more we learn, the more we will understand the rules of the game. You then have a chance to be, ahead of the game and potentially have therapeutic regimes which will stop that next kind of evolutionary.
Order is our route to offering our patients hope for the future.
What's driving Charles Swanton's team of scientists is their goal of finding effective and focused treatments for the patients to offer them real hope. Today, he is seeing Marianne, likewise a biologist, who has survived lung cancer thanks to new advances in treatment based on Charles Swanton's research. Marianne was never a smoker, but particles in the air we breathe may well be the cause of certain pulmonary cancers.
Our pollution work has contributed to a body of literature that shows that inflammation is an important part of the process of cancer initiation. You need two things. You need the mutation in the right cell, the right stem cell, and you need an inflammatory mediator to trigger that mutant stem cell to expand into a tumor in lung cancer.
His most recent work about the pollution, it was a sea change, how we all see cancer arising, certainly in lung, but maybe in other cancers too.
So a future of molecular cancer prevention may be that we could give pills that could dampen down inflammation and stop cancers from initiating in the first place.